This is section 1.1, ratio and proportion, from our chapter 1 on ratios, proportions, and percents. So here we're going to look at what is a definition of a ratio. A ratio is a comparison using division of two quantities of the same kind, both expressed in the same units. Your key here is to make sure you're paying attention to the same units. Okay, you don't want to mix up and have days and years. They would both need to be like days and days or years and years. So a ratio is usually written as a fraction in lowest terms. Okay, so in lowest terms means that we are simplifying. A ratio is used to indicate the relationship of one part of a quantity to the whole, just like a fraction. And a ratio can be expressed as two quantities separated by a colon. And if you ever see it written with a colon, it just means it's read as the word two. For example, I could say 2, 2, 3. So let's take a look at an example. If I have a kindergarten class of 20 students, and it has 2 teachers, then what would be the ratio of students to teachers? So we are looking at students to teachers. So I'm going to write this as students over teachers. So that means 20 over 2 or 10 over 1. So you can see it as a fraction 10 over 1 or written 10 to 1. Another example of ratio, on an evening shift there are 4 nurses and 36 patients. What is the ratio of nurses to patients? So we're going to do 4 over 36, and of course always simplify. So on your TI 30x2s calculator, it actually will simplify for you if you type in 4 ABC 36 equals, and you will get 1/9. Some more examples. A typical gear ratio for the first gear on a car is 3.54 to 1. This just means that the engine makes 3.54 revolutions for each revolution of the drive shaft. An adrenaline injection of 1 to 1,000 means that the injection should contain 1 part of adrenaline for 1,000 parts of the solution. So here I'm going to look at another example. This is from page 16 of your textbook. You should be able to access the e-text through your MyMathLab, and if you have any questions about that, please let me know. So in number 2, I have a picture of, it's 2 circles here, and we have like a pulley system, and so the diameter of the big circle is what we're going to call A, and the diameter of the little one is B. And then there's a pulley system around this. And in number 2, you are being asked to write the pulley ratio, A to B. So if for part A, or question A, it's 16 inches and B is 6 inches. So all you would have to do is 16 over 6, and of course always simplify that, and remember you can use your calculator and the ABC key, and you should get If you are using your ABC key, it probably gave you something that looks like this, 2u 2/3. This just means 2 and 2/3, but we would want our answer as an improper fraction. So if you press second ABC, so that is second, and then the ABC key, and the equals or the enter, you get 8/3. So what you should have been noticing is as we are creating these simplified fractions, we are actually creating proportions. And a proportion is a statement or an equation that two ratios are equal. So for example, the ratios 2/5 and 10/25 are equal. And so they can be expressed as a proportion of 2/5 equals 10/25. So how do you know that they are equal? You can check by either simplifying 10/25 or do cross multiplication. 2 times 25 is 50. And 5 times 10 is also 50. And because those are both 50, then they are equal and it is a proportion. Okay, so here we have the kindergarten class of 20 students, and it has 2 teachers. If the class grows to 30 students, how many teachers should be in the class to maintain the same student-teacher ratio? So we can write this as a proportion. 20/2 equals 30/, how many? So because I don't know how many teachers, I'm going to put my X there. So because problems can be set up as proportions, we can use the cross product rule to solve them. So here you're seeing that A over B equals C over D. So I can say A times D to give me AD, and B times C equals BC. And this is saying, okay, well, if I cross multiply a proportion, then I should have equal sides. So let's take a look back at the kindergarten class example. We already wrote our proportion as 20/2 equals 30/x. And we are looking for how many teachers should be in that class. So if we cross multiply, so again, you should do 20 times x and 2 times 30. So 20 times x gives me 20x. 2 times 30 is 60. And now you have an equation that you can solve. To solve an equation, then I am going to have to undo my multiplication. So the opposite of multiplication is division. So I'm going to divide by 20 because remember, I'm trying to get that x to be 1 or be it by itself. Whatever you do to one side, do to the other. So now I'm left with x equals 60/20 is 3. So to keep that same student-teacher ratio, we would need 3 teachers. So here, let's look at the pitch of a roof. So the pitch of a roof is a ratio of its rise to run. So we can write that as a ratio of rise over run. So think of pitch as slope. So if I'm taking a look at a picture, then my rise is from the bottom of the roof to the top, and my run is from the middle of the roof, so from that point to the side. So if the pitch of a roof is supposed to be 4 to 15 and the run is 30 feet, what should the rise be? So if this is your question, you can figure out what the rise must be by creating a ratio. I'm going to do that. We know it's supposed to be 4 to 15. Okay, now remember again, pitch is rise over run, and we know what the run is. The run is 30 feet, and we're looking for the rise. I have my proportion. Now I'm going to cross multiply to solve. So you're going to do 4 times 30 and get 120, and 15 times y for 15y. And then solve, so divide by 15, and 120 divided by 15 gives me 8. So y equals 8 feet. So here we have medication TTQ is available only in a liquid formulation with a concentration of 25 micrograms per milliliter. How much of this liquid formulation should be given to a patient if 300 micrograms of TTC is ordered by a physician? So we know that it is 25 micrograms per milliliter, which means per 1 ml. And we know that the patient needs 300 micrograms, so how many milliliters are they going to need? We can solve this by 25 times x gives me 25x, and 300 times 1, so that's 300. Divide by 25, so we can solve for x. And 300 divided by 25 gives me 12. So they would need 12 milliliters. Here's some just basic examples from your textbook, page 16, part B. So I have 2 over 15 equals 8 over h. And to solve for h, we're going to just do that cross multiply and divide. So 2h equals 15 times 8 is 120. Divide by 2, so h equals 60. So what if your ratio has decimals in it? You can do the same thing. So this is number 12. If I do 3.25 over 1.5 equals 8 over 0.6. The same rules are going to apply, so you're going to just do 3.25 times 0.6. And that gives me 1.95. And 1.5 times a is 1.5a. Divide by 1.5. And that gives me 1.3. So 1.3 equals a. You can do these extra practice problems, and if you have any questions, please ask.